Yeah, we're at the top of the hour now, so it's time for us to be really thankful and grateful to have Kirk Harnack with us. And Kirk's got a presentation that I think is going to be really interesting. So over to you, Red Leader.
Red leader, that's great. You know, that light bulb there really is from the top of a tower. It came out of Lula, Georgia, courtesy of Charles Kinney. And then, of course, I didn't want, 1,300 watts of incandescent power warming up my office here. It gets warm enough down here. So I replaced it with a couple of 40-watt equivalent LED bulbs. So I think there's a grand total of probably, 22 watts of power going through there now.
Gets the job done.
It gets the job done. I thought about making a flash, but that's just too distracting. So, yeah, and then I had it on one of those Wi-Fi controlled outlets to cycle it on and off. Have it off when I wasn't down here. And I thought, I need the Wi-Fi controlled outlet elsewhere in the house, and this thing only draws 22 watts. I'll just leave it on. And I can no longer see, but I take it that you are seeing TELUS Alliance. Love what you hear.
We are.
Okay. And just to remind you of who I am, that's me. Because I'm so old, they've named me the Senior Solutions Consultant at TELUS Alliance. I've been there longer than most people, I suppose. You've probably seen advertisements that look like this in the trade magazines. And one of the points of confusion that this advertising has created, maybe they did it on purpose in the marketing department, was people ask me, wait a minute, how am I mixing on my phone or my tablet? Do I have to get Livewire or AES67 to my phone or tablet? And of course the answer is, well, no. We're controlling a mixer from your phone or tablet. We're not actually mixing on the phone and tablet. Which brings me to a tiny bit of history here. I love looking at pictures of older studios and things, and you probably do too. It used to be that the console was the center of absolutely everything. In fact, it was so much the center that all the wiring typically in a studio went to the console. So this is out of an LPB console. I think this one is in Clarksdale, Mississippi at WROX. And we all remember these days. Maybe we still do it here and there in studios where everything comes to the console, and the console is the center of everything. This one's even a place where they put all the Post-it notes, apparently. And even when we went to digital consoles, AES EBU ins and outs, and digital infrastructure inside, that console was still the center of everything. It all wrapped around and depended upon the console. And, graphically, our consoles, our studios looked like this with everything wiring to that. In fact, we used to purchase a console. We used to size the number of faders based on how many things we had in the room that we needed daily. And then, of course, if we had AB or ABC inputs, we might put some lesser used items on the B or the C input if we had those options. But these days are a little bit different. We tend to have network-centric facilities. If you've done any kind of AOIP, whether it's Lavo or WheatNet IP or Axia or Dante, you know that your audio architecture is now very much network-centric. And even though it looks like, there's an Ethernet switch there in the middle that looks like the middle of everything, certainly with the IT options that we can have redundancy there. We can have backup switches, and we can have spanning tree protocol to automatically, pretty quickly, handle failover if a switch dies. For myself, I've actually never had a Cisco switch die on me except on a power reboot. I just had one here at my office before the Madison show. I was packing up to go to the Madison, Wisconsin Broadcasters Clinic, and packing up for that, and I restarted the switch, and it didn't come back up. So I real quickly had to use an Axia switch, actually. Well, a lot of broadcasters have expressed to me and to us at TELUS that they've got some additional problems these days. They need to mix more audio than they did before, either for on-air or for production, but maybe for voice tracking, maybe voice tracking at home. Maybe they've just signed on an HD2 or an HD3 station, and maybe it's not automated quite all the time. Maybe they do something live on there. Or streaming, maybe they do break away the streaming and do something different, like for ball games or special programming. Or some on-demand program. They need some place to cut up files and prep them for an on-demand online system. But they don't want to actually go to the expense of building new studios. They would like something, hey, we just need this every once in a while or once a day, or can't we do something else? And so our solution has been to think about how to add mixing and control to an existing AOIP network by adding a browser-controlled mix engine. Now, on a similar track, about 4 or 5 years ago, our partners over at Broadcast Bionics in the UK, they did a little informal survey around Europe, mostly in England, but they asked other people too. They said, thinking about studios of the future, what would you like to see? Would you like a bigger audio console, a smaller one? Would you like more buttons and knobs or fewer buttons and knobs? And at least among the commercial broadcasters, what the answer was, no. The talent said this, by the way. They said, nope, we'd like more cushions and daylight. Huh? What does that mean exactly? And apparently what it means is that they'd like actually less audio console. They'd like fewer buttons and knobs, and they'd like more stuff to just work automatically. They'd like to just walk in the studio, maybe bring their iPhone with them or their iPad, and maybe even they walk in the studio and have Bluetooth recognize who's in there and bring up a customized little mixer panel on their iPad or on a screen that's in the room. Maybe that's what adjusts automatically. They'd like less stuff so they can focus more on looking at each other if they're all in the studio together. Just a whole lot less to deal with, because we've had that for decades now. We've had big audio consoles with lots of knobs. So let's jump back into this idea of iQs. This is Telos's idea of one way to address this need. iQs is a virtual software mixing console, and we'll look at a couple ways that's available. It's available as hardware, but it's also available purely as software. And we wanted to make it so that, quite fortunately, these days HTML5 is really good. There's an amazing amount of stuff you can do in it. And so we can get really fast screen updates. We can get meters that look every bit as good as a meter on an app, or a meter actually physically on a console. We can get fader action that is immediate. We can get button action that's immediate. It's pretty amazing what we can get out of an HTML5 browser window. And so that's the direction we decided to go with this. And whether it's a phone or a tablet, or it doesn't even matter what the OS is. This works on a browser running on Linux, or on iOS, or on Android, or on Windows or Mac. It doesn't care. The browser protocols are exactly the same. And so we thought of a couple ways to deliver a product that would let you just connect to it with a browser. And one way is an appliance. And the appliance is a little box that we're making called the AE1000. I thought AE would stand for audio engine, but no, the marketing department tells me it stands for application engine, because it may not always be audio. Okay. So the application engine AE1000, and you can buy that with the iQs software pre-installed on it. And trust me, it's a little bit complicated. You want it pre-installed. You don't want to think with that yourself. The other way that we thought people might want to buy it, because some people told us they want to buy it this way, is as software. It's a software download. In fact, you can download it today. You can install it today. You can run it without a license. You'll just get some very loud and nasty beep tones. You don't want to transmit them. They just sounded really annoying. But about every 30 seconds or so, there's some tones in the audio, and you get 4 faders. But you can download that now. But in a minute, I'll tell you, the format in which it gets downloaded. So it can run on either kind of platform like this. And we'll have in fact, in a few minutes, my colleague Milos Nemchik from California, Milos is going to actually install this in software as we watch. So on the hardware side, here's the piece of hardware, 1 rack unit, and I've got a short video coming up about this. On the back side, there's a lot of holes plugged back there. There's actually no audio in and out. Here's the secret. When we developed the Affinity line of IP intercom systems at Telos, we designed a new board to do that. And we thought, let's make this board able to do other things as well. So we're actually doing a number of different products with this particular motherboard that we designed. It has 2 very fast ARM processors on it, and it can have audio I/O on it as part of our intercom line. But in this application, we just have a power input, 12-volt power goes in. It's a captive connector, and we have 2 network interfaces. At the moment, the iQs software supports 1 network interface. And we're trying to figure out if it's really important to have two. The other format that's available, though, is called containerized software. From a branding point of view, it's called Docker containerized software. I don't know if it's easy to take a poll or anything, but I was, most broadcast engineers have not heard of Docker or don't have any experience with Docker, and it's a little bit different than a virtual machine. In some ways, it's more complicated, but it does run a lot more efficiently than a whole virtual machine. So we're going to look at that and how to install that in just a few minutes. But with containerized software, and lots of big companies are running this. I mean, if you send money to somebody with PayPal, you're probably using 5 or 6 containers along the way to get your money transfer from one person to another, and that's all using Docker containerized software. So you have the hardware. In this picture, I've just got an older Dell R710, and the host operating system. In this case, it would be Ubuntu. It doesn't have to be Ubuntu Linux, but it would be some flavor of Linux. And then on top of that runs the Docker real-time application engine. And then on top of that, that Docker real-time application engine, or runtime engine, I should say, it services however many Docker containers are out there, and helps them compute whatever they need to compute. So we'll see how that works. So the iQs, you can use any HTML5 browser. It'll go from 4 faders up to 24 faders. There are like the rest of the iQ console line from my employer, from Telos. It has 4 program buses. It has a record bus also, additionally a telco bus, and of course a preview bus. It can do auto mix minus. It can create a mix minus for every single fader that's active at the time. And so they can be very customizable. And you can talk back to any source that has listening available. It does automatic mic balancing or level balancing using an auto mix feature, and you can set the weighting on that. It has mic processing for all mic sources, even if it's 24 mic sources, and then it has 3-band EQ for any stereo source. On every single fader on your screen, there's a confidence meter. There's a pre-fader level, PFL. It does work with the Axia Pathfinder software, which is kind of like orchestration software. If you haven't used that yet, you can route, monitor, and control sources with an external piece of software, which means you can push a button and literally in Timbuktu and change something on the console back at the station. That's what the Pathfinder software would help you do. It supports the standards for audio like AES67, SMPTE ST2110-30, and it will work with any AES67 Livewire or Livewire source. It'll also work with Dante as long as it's Dante's AES67 implementation. It'll work with WheatNet IP's AES67 also. Of course, it has studio and control room monitor panels, and it's got a little soft key that you can make it do different things depending on what kind of source you're running, like a start next on your automation system. So audio mixing without a physical surface. You can do a temporary studio anywhere. Home studios don't need a purpose-built mixer. And, it's let me move that out of the way. It's also can handle multiple users. Like I think it can handle 10 different users at the same time. So if Bob moves a fader up and down, Sally in a different location sees the same fader move up and down. So they have parallel control. So here's a couple of photos coming up. This one is at one of my radio stations in Mississippi. This is in Greenville, Mississippi. This is our afternoon hip hop guy, Big V. And he's just showing off the iQs there in the same room. In addition to, you see the large element console in that room. In this picture, I've got the AE1000 running. I just put it on the workbench and hooked it up to the Axia network, and all 82 sources on my network are available on it. And so that's how I hooked that up. Here is our station manager in Cleveland, Mississippi, Jim Polliard. This is sitting in a control room that also has another smaller Axia console, but we could replace that Axia console. In fact, it's getting pretty long in the tooth. It's probably every bit of 16 years old. So when it's time to replace that console, we'll probably go buy a big Dell 33-inch touchscreen, and that'll be our new control surface for the morning guy and for production. And then here's another of our disc jockeys. You can put this in an office. It doesn't have to be in a control room. It can just be in an office, controlling that mix engine elsewhere on the studio. And it works fine with a mouse. Of course, it's more convenient with a touch screen. I don't think he has a touch screen here. I think he's just touching it because he thought it'd be cool. All right, I'm going to skip by this question, and we're going to look at some of the technology here. So earlier we talked about studios being more network centric these days. And so, just in case you're unfamiliar, I'm going to we'll get us all on the same page with a real quick AOIP refresher. We start with an Ethernet switch. It needs to be a switch that is cognizant of some of the protocols that are used, like IGMP. That's Internet Group. What is it? I forget what IGMP stands for. Boy, what a senior moment. It needs to have an IGMP querier in it. That is to shut off unused streams. It has QoS tagging, TOS tagging also. More and more switches these days will do this just fine. More and more switches are designed for multimedia, for multicast. If a switch is qualified for AES67 or SMPTE 2110-30, then it'll work perfectly well for Axia Livewire. To that switch, we would add some input-output devices, and that's what the three other devices are shown there. Those are either analog, microphone level, or AES EBU devices. We call them X nodes in the Wheatstone world. They'd be blades. And then, for example, here's some speakers added to an analog output on that X node. Now we can add more functionality to the network. The black box in the lower left-hand corner there, that would be 8 mic processors in one box. That's called the Voco 8. But the way you can hook mics directly to it. It does have mic pre's built into it, but you could also pre the mics elsewhere, put them on the network, and then bring them over to the Voco 8 and process them. The automation PC that's shown there, well, there's no need for an audio card in a PC anymore. We can just run, typically we'll put a separate network interface in there, just drop an Intel NIC in there, and then run the Axia IP audio driver in there to get audio from the application out, excuse me, to the AOIP network, and vice versa. You could record off the AOIP network. Now we throw in a audio control mixing surface, but as is the case with most of the audio mixers in the AOIP world, no matter who the manufacturer is, there's no audio actually in that surface. It's just a mouse that looks like an audio console. So we would have a mixing engine elsewhere on the network. And in this case, you see in the far lower left now, that silver box, that is an Axia Studio engine. And so under the control of the mixing surface, the Axia engine will subscribe to various different sources that are on the network. For example, it would subscribe to the microphones that you may have in the studio. It would subscribe to the automation system output. It could subscribe to satellite receivers, for example. And then it will generate new streams for the network, streams with names like Program 1, Program 2, Control Room Monitor, Headphone Monitor, things like that, Preview. And so those streams go back on the network for output wherever you like them. Now, we can also add, here's something that came out about four years ago. This is the Axia iQs mixing console. And because we could, we decided to go ahead and put the mixing engine in it. In fact, the board that is in this console that does the mixing, it's actually just bolted in a case to the bottom. And it's the same board as in the AE1000 I showed you earlier. I mean, it's slightly populated or depopulated as needed, but it's the same board. And so that gives us some mixing capability within there. And the point there is, when you're in a console-centric world, you can add a fair amount of functionality to your network just by plugging in one thing. If that one thing is, say, this console, this iQx. So you've got an existing network, but you need one more control room or to do something, or you've got an extra ball game to mix. You can literally plug this in the network, subscribe to the sources that you want, and mix them together and have the output available on the network. And if you need some local I/O for that board, it does have an extra port on it. You can add something like an X node to that. All right. So what if we change some of this stuff? What if we got rid of the hardware mixing console and we put in some software mixing consoles? Now we're still controlling that same mixing engine down in the lower left there, but this is an application. It's a Windows app called Soft Surface that we came out with actually some years ago. And during the pandemic, a lot of stations have told us what they did was they just ran Soft Surface on a computer at the station and then sent the talent home, and the talent would remote desktop by whatever brand of RDP they wanted to into that computer. You can run this software remotely, but there's a lot of ports that have to be opened, and it really wasn't meant to be used outside the LAN. You could also do a VPN and logically be on the same LAN. There are other software products on the market, not from Telos, that let you do the same thing. This is a tablet software. It's called IP Tablet. It actually runs on a Windows tablet, and it's from a guy in France who writes some really fantastic software. But it's highly customizable. You can put faders on it, telephone control, intercom control. You can have HTML frames on it. So there's a lot you can do with that, called IP Tablet. And some people have even used Telos's own Pathfinder software to make panels. So you can make customized panels that have faders or buttons, and you can control a console or routers, or even in these X nodes that we talked about earlier. Those X nodes now have mixing points in them, so you can mix. You can subscribe to things, mix them, and send them back out, and control the level of them using IP Tablet or using Pathfinder software. So there's lots of interesting possibilities when everything is on the network. Now here's one more addition we're going to make. We just added that AE1000, that 1RU silver box above the Voco 8, and to that we're also going to add on the network a tablet. So now we can subscribe to more and different things on the network in that AE1000 and control it all with that tablet that's shown there. Well, there's even more we could do. We could put a bunch of AE1000s in our station to control, have multiple consoles, and then we could have multiple different devices to control the mixing. Now I'm showing 2 of these things wired to the network and 2 of them on Wi-Fi. Now, normally, you can't put live wire on Wi-Fi. It's just that Wi-Fi is not built for the immediate needs and zero buffering of live wire. So, but we're not running live wire to these control devices. We're just running a browser. So you could put these things on Wi-Fi and have perfect control of your mix that way. Now, the other option, instead of the hardware things, you could just stick in, one or more pieces of hardware, like a server platform. I kind of like server platforms. I don't know a lot about them, but they do have 2 power supplies, and they have lots of redundancy inside, and 17 fans. So if 2 of the fans die, it doesn't matter. It still runs anyway. It'll warn you, but it still runs. So this is where the software version of iQs could live, and multiple copies of it. In fact, here at my office, I did put 6 containers of iQs on an old Dell R710 machine, and not much money involved, and I got six consoles. So we control with any modern browser. We know that. There's what we've designed as the control surface to look like. I think we're coming up with some options there. If you don't like what you see there may be some options to move buttons around, make things have fewer buttons if you want to. So that's all coming. And again, the 2 deployment options inside a piece of hardware with iQs pre-installed, or deploy it yourself as containerized software. And not wanting to make this a sales presentation, but because one version is software, the hardware version would be a buyout. The software version could be a buyout, or it could be a subscription. So if your OpEx dollars exceed your CapEx dollars, you can subscribe to a console. Just get your subscription. Add faders if you want to. You can actually get faders for a short period of time. So I'm going to show you a short video here, and some of what I'm going to tell you on the videos may be redundant to what I said, but it'll put the point home, and we'll actually install this little audio console. So here we go. Hi, it's Kirk Harnack to tell you about how you can get the iQs virtual audio console pre-installed on this hardware. This hardware is the Telos Alliance AE1000. AE stands for Application Engine 1000. When you order the AE1000 with the iQs software pre-installed, what you get is this diminutive box. Of course, 19 inches rack width, only 1 rack unit tall, and look, it's only 4 inches from front to back. By the time you add power and Ethernet connectors, it's still under 6 inches from front to back. There's no fan in it. It doesn't even run very warm, but it's amazingly powerful. You can put up to a 24 fader iQs virtual audio console in here. That's right. Plus it has extra buses on it, all the buses you'd need, program 1, 2, 3, and 4. It has a recording bus. It has a telco bus, it has an offline bus, and it also does audio processing. It will process your microphones, of course, for downward expansion, compression, and de-essing. Plus, it has stereo EQ available, 3-band parametric EQ, for each of the inputs if you want that. There's also a monitor section and a headphone section and a preview monitor as well, plus a studio monitor section. All the things that normally come with an iQ console are available in this iQs software virtual console on the AE1000 platform. Let's hook it up. So once we have the AE1000 with the iQs software installed, we can hook it up to power and Ethernet. I've got this Ethernet cable here already connected to my Axia network here in the office, and I'll take the power coming from the 12-volt power supply. Now this is a locking connection here, so it screws on, won't come off at all. And now the power indicator comes on. Once it's up and running, you can browse into the unit using the default factory IP address, which is 192.168.2.29. Just set your computer to the same LAN address and browse right into it. From that point, you can set the IP address to what will be compatible with your own internal Axia Livewire or AES67 network. Now that you've set the IP address, just browse to that address. In my system, it's 10.216.0.29. And you're challenged with a login. The default is user with no password. Now, the next thing we'll want to do is set up some sources and some shows. So we can go to sources, and I've already set up a number of sources that exist on my network here at my office, including a host mic, a computer that can play audio for me, the output of my Omni 11, and some audio receivers that exist in my rack room, plus my Zip 1 and some audio from my Zipstream hardware. We'll also want to set up a show to bring up. And so I've brought up one called iQs Demo. And in this one, I've assigned the host mic to come into all 4 program buses. I've also brought in some tuners, my Tivoli FM tuner, a couple other receivers that I have, Zip 1, even the Omni 11 comes up. And I don't have any sources on any of the rest of the faders. I guess I didn't need all those faders, did I? The iQs can also be used with Telos phone systems, and you would set that up here. There's also a monitor section, so you can decide what you're going to monitor by default when you load the profile. And you can also send the preview into the rest of the monitor feed if you like. You can also set up which external inputs will come up when you bring this profile up. All the usual selections that exist for an Axia iQ console also exist in the Axia iQs console. Now we've selected that. The iQs demo profile is active. So let's go ahead and look at the outputs now. I've turned on some outputs, program 1, 2, 3, and 4 on my network. You can choose multicast or SIP unicast. SIP unicast is useful if you're in a server environment in a public cloud space, especially where multicast isn't allowed. You can also give it a channel IP address, channel address for Livewire, or an IP address for AES67. And you can choose what type of payload it is, standard stereo or AES67. Okay, we've seen enough setup. Let's go see what it looks like when we bring the Surface up. So I'll click on Surface, and it's connecting, synchronizing the state of the console, and oh my goodness, there we are. Let's look at the iQs Virtual Audio Console in operation here. I've got a Microsoft Surface computer that's being used to access this iQs software running on the AE1000, and it's got a touchscreen. I also have a large monitor here so you can see it more easily. Of course, a large touchscreen monitor would work just as well too. I'm going to bring the monitor volume up, and you can hear the monitor come right up. I got 4 different radio stations running here on these 4 different faders in the 4 different program buses. And you can see I can switch, watch it, I can switch to different program buses and hear these different radio stations.
1, 2, 8.
I can bring this one up and down, for example, all the way down, all the way up. I'm just touching the touchscreen. I can also double tap to bring it right up to 0 dB if that's a quicker way to do it. Again, you can grab anywhere on the orange bar here to turn this up and down. There's an example. You can turn it off, of course, turn it back on. You could also use the mouse to do the same thing. I'll show you over here. Turn it off and turn it back on. We can also put something in preview. There, we've put that in preview. I've got preview mixed in with the monitor. We can turn the preview level up and down separately. just like that. Take it out of preview here. And we can also mute the microphone, mute the speakers by turning the microphone on like that. And in fact, we'll turn off all of this. And if I just talk, I have the microphone, this microphone right here, through here on the Axia network, and you can see my voice coming through the monitors as well. So lots of options here, and it works just like your regular console does, like any iQ console does. The iQs virtual audio console running right here on the AE1000. Okay, well, that was easy enough to install a piece of hardware and plug it in and grab those sources already on the network and listen to it. So let's talk about the virtualization aspect of this, because that's where a lot of people think that this is going. I was in Madison, Wisconsin a couple weeks ago, and after half a day of the initial presentations, our friend Chris Tarr posted on Facebook. He says, well, I guess I better learn about Docker because that's where everybody's going. So it turns out we saw a presentation. It wasn't from Orban, but it was with some people who are involved with Orban. They were talking about Docker containerization. Enco with their Encaption product is going that direction as well. And I suspect we'll see a lot more. So I guess a lot of us are familiar with virtual machines, right? So you have a hypervisor like VMware or Hyper-V, or KVM, and then you install a whole operating system on there, and then you install one or more apps to do something. And certainly I'm doing that at some of my radio stations. The only problem with a virtual machine is you do have a lot of overhead there that the app doesn't really need. And if you're deploying 3 or 4 virtual machines, okay, but if you're deploying 300 or 400 or 30,000 or 40,000, then that's a lot of overhead. That's a lot of hard drive space and a lot of CPU space, CPU cycles being done to do things that just don't got to get done to accomplish your goal. And so a group named Docker about 10 years ago came out with a standard for containerizing software, where you'd have a number of containers, a runtime engine that was servicing those containers. And the runtime engine, if the container needed some code or something that the OS had, well, the Docker runtime engine would go and service that. It would go get that code for you and run what it had to run and then return it. Of course, with CPUs running in the gigahertz category now, it all seems to happen instantaneously, and it happens quickly enough such that running audio through it in a real-time fashion is not a problem. So with Docker is considered by a lot to be the future of computing services. Microservices in containers are the industry future trend for software, and groups like Google, Amazon, Visa, PayPal, MetLife, they're all using Docker containers for critical applications. Let me skip on past that one. So let's just jump right into what this looks like getting installed. This is my colleague, Milos Nemchik, and I want to point out carefully that this is not a tutorial on how to install this. Milos has the whole environment set up exactly right so that this demo would go very quickly. He actually installs a console in about 4 minutes, and we do about a minute and a half of other talking too. So the first time I installed this, it didn't go as well as it did for Milos, and that's because I did something stupid, didn't follow the directions or whatever. But let's watch what Milos does. And he's going to, by the way, Milos used to be chief engineer at some Clear Channel stations in I think San Luis Obispo, California. So he's certainly been in broadcast for quite a while. Let's see what he says. Hey, it's Kirk Harnack. I'm here with Milos Nemchik, who's the project manager for iQs, our product manager. Hi, Milos. Welcome in.
Thanks for having me, Kirk.
So one of the ways that you can have iQs, the audio console that is remotely accessible with a browser, is by running it as not quite a virtual machine. It's running as a software container on what kind of platform?
On a Linux machine.
Okay, Linux machine. So let's, if you would, just take us through this. We're going to show a screen here, and you can tell us how this process is working. Here we go.
Right. So I'm at a prompt for logging into the Linux machine, and I type in my username, my password, and now I've got access to it. And I'm going to zip on over to our online documentation, and I'm clicking on the Docker container documentation. And because I've already pre-read that, I know exactly where I need to go, but it's suggested to read all this material. What I'm scanning for is the Docker setup, and midway through the page is a string of text
Ah,
that I want to copy, and I'm copying it there.
and that is a script, a single line script, right?
Single line scripts. I've pasted it into my prompt, and I hit enter, and now it's asking for my super user password.
Okay.
And then it proceeds, and it's checking various elements in the Linux machine to see that they're there, and if they're not, it installs them. And this just takes a few
And folks-
seconds.
Yeah, folks who've installed programs with Linux before, they'll recognize this process, right?
I think so. It's very familiar. Yes.
Yeah.
And so it's checking for example, like the Docker engine, if other utilities that we like to use are present. And again, if it's not there, it tells you that it's there or not there. And if it's not there, it installs it. And so now it's asking for the login to our repository, our online repository.
Okay.
What happens to be at Kwe.io. And so I'm giving my username and my password for my access. And so
And so one
Go ahead.
prerequisite is that a person would already need to have an account with Kwe.io to get this.
correct.
Okay.
Correct. And it's asking for a network setting, Telos Mac VLAN, which I'm not deploying in this example here because I'm just doing a single instance of iQs. And so then it asked me if what product I want to install, and I'm type 1, which is the iQX console. And it's giving me questions for certain things like the name of the instance. I just typed in XYZ as a call letter. So no, I'm done with the script. That's it. It did everything. And now the Linux machine is a certain IP address, which I happen to know. And I'm going to type that into the URL. And it's just a 101.49. And there it is. There's
Oh, wow.
iQS. And first thing is to log into the iQS products. Let's create a source profile, which allows me to ingest audio from the network into the console. And
Okay.
my favorite generic Muzak source profile, I'm typing in Muzak, and I'm going to pick an audio source in my test environment here. And program 1, or the monitor section of the AE1000, which we're also talking about. And all the defaults are good. I'm going to also select configure an output,
Okay.
so I can hear the audio without any output, right? So in this case, I'm just gonna enable the monitor output. I'm gonna give it a LiveWire channel number, enable it, and hit apply. And now my monitor section of the iQS is in my network, and I can pull it up in my headphones or speakers. And here I'm on the user interface. I've pulled Muzak up. I'm going to turn it on. I'm going to assign it to program 1.
Oh,
Fade it
look at
up.
that.
Don't forget to turn the monitor on. That was the last bit. And now I can listen to Muzak as I read the rest of the online documentation and figure out how to make this product work.
Oh my goodness. So, all right. So what we just saw, folks, was not a complete tutorial on how to install iQS in a Docker environment, a software container environment. What we saw was that you can do it. If you have all the prerequisite information, you can do it quickly. There is some prerequisite information to do, including getting an account with Kwe.io, which is our repository for the software that you get it from. Yeah?
Mhm.
Yeah, okay. And then you just made a very simple console. After the software was installed and running, right? Now we're going to access it with an HTML with a browser. And you established one source, and you established one output. Obviously, you got to have one in, one out to see what you're doing, and then you browsed to the console, and there you had it.
Now, one thing we did not cover in that video was the licensing. It does require a license. And so without the license, what I received was a 4-channel mixer, fully functional, except we have tones that are generated every, I forget the time period, say 30 seconds.
Yeah.
But
Okay.
the license process, you would install the license server, get a lock request phase, send that to Telos. Telos will give you the key, and away you go.
So it looks like, honestly, if you have the prerequisite stuff available, you have a Linux machine ready to go, and you can go ahead and install the software, and you have your license ready. You went from start to finish there in, I think it was just under 4 minutes.
Yes.
Yeah. Wow. Milos, thank you for the demonstration. Again, not a complete tutorial. We'll have other resources for the more complete tutorials, but I wanted to show folks that it can be done. You just install an audio console.
Yeah, in 4 minutes.
In 4 minutes. Whoever thought we'd be doing that? Milos Nemchik, product manager for Axia. Thank you so much for being with us.
Thank you, Kirk.
All right. Well, it may have been 4 minutes, but it certainly was some setup there. Let's see. A couple of people ask about, okay, well, what about audio monitoring? And at the moment, we have the philosophy of crawl, walk, run. So this is certainly the first product that is a broadcast quality, a broadcast featured software mixer. There are other non-broadcast mixers out there. So right now, at the moment, the iQs software does not have any actual audio I/O capability built in. So if you're using it in the facility where you're at, like those pictures that I showed earlier of Big V and Jim Polliard and Mark Green, if you're using it in your facility to add extra studio functionality, well, you've probably got Axia nodes, or Wheaton, whatever you got. You've got the ability to get audio in and out right there. So you could get audio out of an Axia node, for example. If you the other situation would be if you're remote, if you're at home or something. Telos does make codecs, so you could certainly hook up a codec and get audio to and from. Now that said, look, just between us girls, yeah, of course, we're working on audio functionality built into the browser, and in fact, on some of our other products, we have a big audio console called the Quasar. Pretty soon, the Quasar will have a software remote control feature that will include audio monitoring. And eventually, I'm sure that these will include audio contribution from the field. But for now, this is a control only. You provide your own monitoring by whatever means, if you're local or if you're remote, through a codec, as an example. Where to install this? Well, you could, of course, install it on premises, as many people would do. Some stations, some groups have a private data center where they have other things. And then this also does work in public cloud. We've got this working at Amazon Web Services, and I think we've had it working at Google, either Google or Microsoft. Before you think about doing this in the cloud, realize that there are some interesting expenses that may add up over time. There is a very, very large content creator, kind of broadcaster, that is looking at using cloud instances to mix a lot of on-demand or short-form programming. And they've looked at the costs, and they've decided that when they're not doing an actual program, they will not just leave things up and be set. The expense here is not so much the compute instance, it's the constant data going back and forth for audio. Certainly if you do linear audio like Livewire or AES67, or even a linear non-compressed version of a SIP connection, you would incur some expenses over time. If you do some coded data, like using an Opus codec or a codec from our company, for example, we're doing Opus codecs in some instances. Yeah, obviously that gets the amount of data down, but ingress and egress is the term here, and that does cost money from those providers. I've got one more little short video here, I think maybe 30 seconds worth, just to demonstrate the capability of controlling this from different places at once. The Axia iQs Virtual Audio Console can be accessed from more than one browser at a time. Here we're accessing it with one browser on a computer and a second browser on the same computer and another browser on a second computer. Then across the office, we're accessing it with 3 more browsers on 2 more computers over there. And what's cool is they all track together, so you can work together. Watch, I'll move this one up and down, and on another computer elsewhere on the network, it also moves up and down really fast. So people can work from anywhere and collaborate together with iQs. So that was fun to set up in the office. A lot of screens. Son came down and said, "Dad, what are you doing?" We'll skip by that. Let's see. I doubt too many engineers on this call. Well, let me put this a different way. A few years ago, I installed a fairly complicated Telos phone system at a TV station in Oklahoma, so they could do tornado play-by-play with people in the field. It was like the movie Twister on steroids. And I was a little surprised to find out that at this TV station, like many TV stations, they did not want to know anything about how to troubleshoot it or repair it or anything. They didn't really want to know how it worked. They want to know how to use it. And as a radio engineer, it came as a surprise to me to find out that more and more organizations are willing to pay for a service level agreement to get somebody else to come out and work on something. And my more recent work in TV, certainly Avid and other systems are like this. The TV engineer is typically not the person responsible for for individual troubleshooting. So TELUS is offering a service level agreement because people have been asking us about it. Just want to make sure you knew that was available. Okay, so we all know what it is. I won't need to repeat that. And available in several different formats. And I think it's time for Q&A. How about that? Let me stop that share and so we can take up less screen space with that.
Well, Kirk, that's really interesting. And we have at least one or two questions here. Does iQs have capability for GPIO using the appropriate nodes?
Absolutely, yes. It is functionally identical to our iQ consoles. So almost all the screens are the same, and GPIO is part of the whole protocol. Yes. So you can push a button on a touch screen and have it show up as a physical collector to ground somewhere else, and vice versa. You can have an indication coming, like you can have a ready light from your automation to actually light up the off light on your iQs before you punch it on. So yeah.
All right. Now, suppose somebody just really wanted to have the very simplest setup for, I don't know, going out to a football game or to set up a home studio just to track stuff.
Mm-hmm.
For faders, is there EQ available?
Yeah. So no matter how many faders you have, every single fader, if the source type is a microphone, then you get mic processing available to you. It's mono processing, but it's your standard. It's a lot like a Symmetrix 528. But every input has EQ available, stereo EQ, and that EQ can be defined along with the source. So in other words, it does, you can define it such that it doesn't matter which physical fader, not physical anymore, is it? Which virtual fader you put it on, that EQ setting will stay with it. And this brings up an interesting point that I think is worth mentioning. A few years ago, I put an Axia system at a rock station in Chicago, in Boston. And on an overnight, I totally configured a big console of ours, and they told me to not be in the room when the morning crew was there, but to check in with them after their shift. So I didn't come in. I slept in, came in at 9 o'clock, and I knew that they used their ISDN, their Zephyr, quite a bit. They used it for live remote broadcasts, and they used it for the traffic reporter in the morning, some third-party service. And so I came in, I said, how'd you like the console? They said, yeah, it's fine. Yeah, we understood it just fine. No, but oh, wait, they said there is one problem. We noticed that the traffic lady, when she calls in and we have her turned off and our mics are turned off like we're playing a song, yeah, she can hear what we're saying in the room here. I said, yeah, that's a feature. That way you can talk to her without having to push a talkback button. You just have this, it's called Talk Around. It's a Talk Around bus. It actually the idea came from PR&E many years ago, or an offline bus, it's sometimes called. And they said, yeah, well, we don't really want that. I said, well, how come? She says, well, sometimes we say some not so nice things about her and we don't want her to hear that. I said, oh, okay. But you do use the same Zephyr for like store remotes in the afternoon. I heard them yesterday. They said, yeah, we do that. I said, well, would you like to be able to talk to the guy at the remote, without having to push a talkback button? They said, yeah, that'd be fine. I said, tell you what, in the morning show, when you load your morning show profile, it'll say traffic. It'll really be the Zephyr, but it'll say traffic, and she won't hear what you're saying unless you push the talkback button. And the rest of the time, you just bring up Zephyr or ISDN or whatever we named it, and you will have talk around. So whenever you're all turned off, he'll just be in the speaker. You can talk to him, blah, blah, blah. And they said that would be great. So what I did was I basically defined the same source two different ways. And I named it different names so that my point there is you can take a microphone and you can define it several different ways. You can call it Molly or Sue or Bob or Bill or Steve. And each way you name it, each way you define it has its own processing and other characteristics that travel along with that name, no matter where you put it on the console. And so if Bob brings up Steve's source mic, well, he's going to have Steve's EQ and processing as well. So that was more of an explanation that you wanted to, but I thought it was a fun story about we don't want her to hear what she's saying, what we're saying.
All right. We have a question here from Ted. He wants to know, can you use the small control surface to remotely control a studio mixing engine?
So what small surface? I'm unclear.
This is from someone's home location if they're working outside the office.
Yeah. So they could just they could you have to have your IT people set this up, or you have to get access from the outside. And by the way, the only security here is password. Oh, and you saw me go into the console at the configuration pages and then click the Surface button, and I got the console. You can create a shortcut for your DJs that they click the shortcut and they go directly to the Surface. And that would be okay for on the same LAN, for people already in the building. You can still give it a password if you want to, but you can click it so they just go directly to the Surface, and then they're not even presented with the configuration pages. Now, if you're doing it from the outside world, then it could be open to anybody. So you're going to want to come up with some kind of a scheme to only allow authorized people in. Now, yes, like I said, it's got username and password, and if you think that's good enough for you, well, that's fine. Some stations want to just implement VPN from the computer that the remote person is on directly into the station's network. VPN is not required. Some of our products would kind of require a VPN because of all the different ports going on, but this just requires port 80, and then it automatically opens a couple more ports for the web sockets. But we have a demo system at our headquarters in Cleveland where you actually have to sign in with your at telosalliance.com account. We go through some kind of security that I think Google provides, or the whole Google workplace provides, and then you have access to our console. I haven't checked into that, but surely engineers could or IT people could implement that at your station. You could have some kind of a credential challenge.
Okay. There are some that are watching on our YouTube live stream. And if you are on that live stream and you'd like to ask a question, just enter the chat box and we will relay it to Kirk for you.
That's a great idea, Barry. Thanks for doing that on YouTube as well.
Anyone else? Just press your space bar or alternate A to unmute and let Kirk know what you think about the iQs or what application you might use it for.
Hey, Kirk.
Yes.
How do you battle either internet latency in the network or over the internet in general? Because there's got to be some latency between the time you hit the button and the time it actually reacts and so forth.
Certainly there is. And I would point out that the only time that human beings would be aware of such latency is if they're, waiting for audio to come back. And I realize that's going to be a problem no matter if you got this system or something else. If you're remote and you're going through codecs and going through the public internet, there's going to be some delay. Now, we already have plenty of examples of broadcasters doing this and it not being such a problem. The one thing I should point out, though, that is if you're a lone person by yourself at a remote location and you're sending audio back and forth and you're controlling something remotely, the delay, as long as it's not stupid delay, I mean, if it's a quarter second, half second of delay, and I think it'd be actually unusual to have 500 milliseconds of delay. I tend to find that this works typically much faster. But if you're by yourself, all tends to work pretty well. The weird thing is if you've got, and even if you've got people in different locations, that works okay. There's, obviously delay like talking on your cell phone to somebody. There's that kind of delay. What you can't have is two people in the same room being mixed elsewhere and then them hearing that back. That doesn't work. Just because you're going to hear it through the air from the person who's, 6 feet away from you, and you're going to hear it again back delayed. So in cases like that, whenever you have more than one person in a studio controlling a mix somewhere else where they hear themselves back, you basically have to do what I would call a super mix minus. You've got to have a local mixer and a remote mixer. And you send your mix up to the cloud, and the cloud sends you everything back except yourself, except everything you're sending up to the cloud. So they solved this problem, or they figured this out a long time ago at BBC in England, BBC local radio, where they have literally 80 studios in 40 cities that operate exactly this way. They have, now they're not using iQs obviously, but they're using Axia products that they figured out how to, the engines are all in Birmingham or London. The control surfaces are all in the local cities. And there is a little bit of local mixing to mix local mics together for the headphones so that they can hear each other in real time locally. And then that mix gets sent up to the data center. But as far as punch start rhythm, it hasn't been a problem. Yeah, I mean, it's really about the same as what cart machines used to be. Or you push start and your turntable, rotates a third of a turn before the music plays. It's really a lot like that. So it's a solvable problem, and it's not that big a problem.
Thank you.
Thank you. And David, thank you for encouraging Barry to put me on today. I really appreciate that recommendation. Thank you. That's a big bunch. Good questions.
Anyone else have something they'd like to ask? Or I find it interesting that we have moved from not just the IC10 that you showed earlier,
Yeah,
but the idea of the large individually wired source on everything console to what could basically sit on a laptop or a Surface or iPad. Just amazing.
Ted's got another question.
Do you have any customers that are using this in an application where perhaps they've got multiple shows during the course of a day or a weekend or something like that, that are originated by one or two individuals in remote locations? And so every hour or every 2 hours, there's a different show happening.
If we have that, I don't know about it directly right now because this product is pretty new. We've had a whole lot of people demoing it, and we've probably I wouldn't say how many we've sold, but it's in the many dozens that people have bought. How they're exactly using it with COVID, I ain't getting around as much anymore, so yeah. I'm not as aware as I'd like to be. For my own stations, I will be using this as soon as we have a need. Multiple people in different locations. Of course, I don't, people have been doing something similar to this. Even here in Nashville, where I live, Lightning 100 here was the first Axia user, 14 years ago or so, here in Nashville. And they bought Soft Surface and controlled their old Element console with that. And different people would remote into it. And use it. In fact, the biggest problem they had, which is the same problem many people had, was somebody at home would establish a two-way connection using Lucy Live software at home and the Telos Zip 1 codec at the studio. They get done with their shift, they'd shut their computer off or disconnect from the RDP program to remote control the console, and they'd forget to turn off Lucy Live. And so the codec is now occupied with nothing, no audio anymore, because they forgot to disconnect, and so the next disc jockey can't connect. They get the equivalent of a busy. So we really didn't have to. I mean, we don't want people to be able to barge in and disconnect somebody else. So I think they ended up remote controlling the Zip 1 to make it. You couldn't even do that. Not with the way Lucy Live works. The person originating has got to shut it off. That's right. You can't even disconnect from it because it's a non-connection connection. So
send out the drone.
Send out, yeah, exactly. Call those. Hey, turn off your Lucy Live.
There was a comment that Donna and I were talking about as we were working on the 100-year stories back in the day when everybody shared frequency. And I guess with Chicago, there was one guy who didn't want to give it up when his hour was over. And the next station sent a worker over and punched the guy out. It's one way of turning the station off.
So if just to follow up on Ted a bit more, if Joe is using this from his house and he's controlling the console, if Mary browses in to the iQs as well. It just means there's 2 people controlling it. So, you know, Mary could move a fader up and down wildly, and hopefully Joe would notice that, hey, I'm on over here. So yeah, you can have up to 10 people controlling it at the same time. Sometimes that's good. Sometimes that might be a bad thing.
Well, I'm just thinking of several different use cases. There may be LPFMs or other stations that have multiple shows over the course of a day that are originating, or ordinarily they'd have, you know, 6 or 7 people coming in and out of the studio over the course of several hours. And if people are originating things from home, being able to do what you're talking about would enable the studio to remain at the studio, them to remain where they are, but still be able to control all of those kinds of things. And I'm just kind of trying to figure out, as we move into our future here with our little LPFM, how that can work as we get some more people involved. We're not there yet, but I'm kind of looking ahead, and maybe there's a use case for other stations that currently have volunteers or other kinds of programmers doing that.
There is a guy who I recently interviewed and on my podcast. I want to say his name is Sean Kelly, but I'm looking for it right now. Okay, where is it? Sean Kelly. This was about a month ago, toward episode number 558. I called it "Master of His Virtual Domain" with Sean Kelly. Sean's a British guy, but apparently he owns a bed and breakfast maybe in Arizona. Barry, I forget exactly where he is, but anyway, he runs 2 or 3 internet stations and has them all running mostly, not entirely, but mostly on Dell servers. And people, remotely. I don't know if he's using iQs or if he's using some other, I don't remember from the podcast, but you could go watch that podcast and have Sean describe what he's doing. And so to answer Ted's question, yes, they do have multiple people doing things. Now, I think they do a lot of voice tracking, but I think they also do some live shows.
Let me frame the question for you a little bit more. Obviously, you can go from the very smallest to a large operation. Can you offer a ballpark figure if a station wants to send a very minimal system out, or just a pie in the sky number for a station that wants to run a big console?
Gotcha. So on the software only version, and I'm sure I'm going to get the, tell you what, if you give me a second, I can probably just bring up the actual price list so I know, because I'm not quite as much in sales anymore. But I can get access to that price list right away to give you an idea of what we're talking about here. Okay, we're going to skip the $30,000 Quasar console. Good gosh, that thing's amazing. Okay, so all right. So that, first of all, on the appliance range, guaranteed success with that. Obviously, the AE1000 appliance itself is list price is about $16.95. The software, the iQs software, it's the same price, $16.95, and that includes 4 faders. Every additional 4 faders is $6.95. So if you got the software only version of it, it's the same price. The Docker container software only version of it is $16.95 for the license, and $6.95 for every additional 4 faders. Now, as software, it's available as a subscription also. You can get a year subscription to a 4-fader console for $845, and every additional 4 faders is $345. So that's for a year.
So
now,
you're talking about, let's say, $2,000 per person. If you have 3, as Ted had, maybe 2 or 3 people coming in.
Oh, I should be clear. That's not a per person. That's the console, and as many and up to 10 people can use it at the same time. It's not a per seat price. That's the console price.
Good.
Yeah. So if you have 50 volunteers, it doesn't cost you any more. You just have to train 50 people what to do.
Well, that was really what I wanted to get to, is that this wasn't something that was just so expensive that it wouldn't be usable for anybody but a large operation.
It seems like the pricing is comparable to a number of other hardware type consoles that you might be able to acquire. So,
Yeah, on the small end that you might have at an LPFM station. Yeah.
But of course, as you say, it is the Telos quality that makes it.
Well,
Yeah.
the nice thing, the remote capability, I use Soft Surface here for our operation. I'm the only one that knows how to run it, which is probably good. But I know we've had back last year during COVID, there were a number of times where we did live shows with everybody scattered all over the place, and I just ran the board from at home. So,
yeah.
you know, this is something like Soft Surface, I guess, is in some ways.
Yeah, with Soft Surface, you had to have a physical console there too.
Right.
So you had that expense, which could be easily $10, $12, $20,000 for the one of our larger physical consoles, and then you buy Soft Surface on top of that for $1,000 or so, and then you'd remote into Soft Surface. So this is the mixing engine and the virtual controls, for $16.95. And I'll reiterate, if you're new to Docker containers, we have really complete step-by-step directions in our help docs on the Telos support website. And if you follow them, you can have a successful installation. A couple caveats I got to point out. Even though the iQs will accept live wire sources coming in, it is essentially an AES67 device. And so it needs PTP clock on the network, as all AES67 things do. Now, if you happen to have an Axia X node, you already have a PTP clock source, because it will generate PTP clock of the required accuracy. Now, it is arbitrary PTP clock. It's not synced to GPS, so it won't be synced to your neighbor down the street or around the world, but it is precision PTP clock. So if you have an X node, you're good there. If you don't have an X node, there are PTP clocks that are GPS. What's the word? Not the right word isn't not informed. Not slaved.
Agnostic.
No, I'm looking for GPS.
Integrated?
Disciplined. That's the word I'm looking for. GPS disciplined. There are disciplined GPS PTP clocks, anywhere from $500 for the cheapest one I've ever heard of to $4,000, $5,000, $6,000 for a proper PTP clock. But you do, if you don't have it synchronized to PTP clock, you will get some dropouts and stutters from time to time.
Okay.
Yeah. And of course you need to have some other, live wire or AES67 sources available on your network. So for demos, I just bring an X node with me, and then I've got, various sources coming into that and a laptop to have computer sources.
So if just kind of thinking about architecture for a minute, if somebody if for example, a station wanted to set up a system where people could remote in, what would be required at the remote end aside from some method of displaying an HTML5 virtual console?
At
like
the
microphone
moment,
or something.
Yeah, at the moment, you would need a microphone, headphone, and some kind of separate codec. It could be it could be a I don't know if Barracks makes a two-way box, but it could be a tie-line, a Comrex codec. Of course, it could be our codec, like a Zip 1, like I have back here. So you need an IP codec to get the monitoring to you and to get your voice, if that person is contributing voice, back to the station as a source on the network. Now, there will come a time when that two-way audio will be available software-wise in the product. Now, honestly, it'll probably be a $1 add-on. I mean, it'll probably be a license feature on it, because not everybody needs that. And Telos and other companies have other codecs too. Telos makes a line of IP intercoms that have Opus codec built into them, so you could use that as well. You could use a software codec like Lucy Live at the remote end, and the Lucy Live Studio running a software on a PC at the studio end. So there's lots of ways to get audio, back and forth. Again, someday I think you'll find WebRTC audio to be available with the iQs product.
Okay, thanks.
I tell you, one of the dirty secret difficulties is that it's a lot easier to do WebRTC in Windows And of course, iQs at the studio is running in Linux in a Docker container. So there's some nice, easy things that we don't have available to us to implement it quickly.
Okay, Kirk, you told me that you had to leave about now.
Did I?
So
Okay.
I don't want to chase you away by any stretch of the imagination, but I just want to give you that option to
Well, actually, I see that the meeting that I had apparently got deleted. So if anybody has further questions, I'm happy to stay. If anybody's sick and tired of me, I'm happy to leave.
Yeah, Kirk, I'm back to kind of, do you have to get the software license and the appliance, or is it just the appliance?
Great question. I'm sorry that's not clear. Our plan is to use the appliance for other products as well. So if you want the iQs software in the appliance, you got to buy the appliance for $16.95 list, and you have to buy the iQs software for $16.95 list. So that would put you up. I mean, at a street price, it's going to be, right around $3,000 for the appliance with the iQs software in it. But that does give you a mixing console. You just need sources to bring into it on a network, either AES67 or LiveWire sources. And then
I was trying to figure out what the advantage was to going to your own Docker if everything was included in the appliance.
Good question. And I tell you, at this point in technology, 10 years ago, that's not a good example. 6 or 7 years ago, AES67 was approved, but most of the engineers in this room didn't know what it was. I had a passing understanding of it, but not a practical hands-on understanding of it, not until Telos came out with more products that actually contained it. So we were at a point, and even going farther back, literally 16, 17 years ago now, I learned about LiveWire and audio over IP, but most people I talked to didn't know anything about it. It was kind of a mystery, like, what? How are you doing this? This doesn't make any sense. Your collision light's going to come on your switch. Well, as it turned out, there's no collision light on switches these days because there aren't any collisions. So it was my point there is a heck of a learning curve. And so this whole thing about Docker and containerized software, it's a learning curve. We are coming up with a webinar soon that and materials, and we already have some online, that walk you through how to install our software, our Docker software. And if you follow the directions literally step by step and don't make any mistakes, it'll work. I've proven that. But I've also proven that if you leave one thing out, it doesn't work. So this is like another thing that I think broadcast engineers, as Docker continues to gain strength, and other people like Orban and Enco and I'm sure others are going to implement it too, or distribute software as a Docker container. We're going to have to learn about it.
Yeah, Docker is fun to play with. When it works great. When it doesn't, you'll be scratching your head for a while to try to figure out where was that one little thing.
Exactly.
I forgot. I have two containers running. I have to wire them together.
Yeah, exactly. Yeah, it seems like there's less visibility into what's going on. You find out things by proxy and not direct. I mean, in our world, hey, if the transmitter's not coming on, oh, look, the back door's open. So the interlock switch is open, right? There's a lot of visual cues in what we have done traditionally. But what's going on inside the computer, you got to find that out through other means. Let's see. I look, I think you're on the cutting edge of seeing what's available, what's coming up next. There are a few people that are just jumping on this, like, this is perfect. And other people are like, I'm not comfortable with this at all. Maybe the appliance. So I can see if you already have an Axia facility and you need to add some functionality, buying the appliance is pretty much a no-brainer. It installs, you already know how to install it, basically. The Docker thing, I made it work because I had to make it work, and I, failed the first time. By the way, I also installed it on literally a $125 used Dell desktop that I bought at Walmart.com. I wanted to see if I could do that. So I bought this Dell Optiplex something or other, not very powerful. I think it was a Core 2 Duo processor. And I installed Ubuntu Linux on it. And that was free, and it took 20 minutes. And then I ran the script like Milos did, like you saw Milos do. I ran that same script. It installed the console on there, and I've been playing with it. I even brought it to the Madison show. We had it running, but we didn't get a chance to actually show it. But it was running, and it works. So you can literally take a $125 computer. Not that I recommend that, but you can and have a console. Some people have complained, why would you use Ubuntu? You know, the Linux version I like is so much better, whatever I like is. And we had to choose something because sadly, and I heard Linus Torvalds complaining about this recently, seems like every distribution has a different file structure. And if we're going to write a script so that people don't have to go through a whole lot of machinations, they just run a script and answer a few questions, we had to choose something. And apparently the guy who chose it thought Ubuntu was great. They have the version we were using was 20.04 LTS, which is long-term support. So it should be very stable and fine for 5 years or so.
I have Ubuntu running on a virtual platform on a Mac Mini, using Windows 7 to do music creation and what have you. It'd be kind of interesting to do that with Parallels on the Mac and running Ubuntu on that.
It would. Now, I'm told, it sounds like what you essentially have there would, I think, be classified as a type 2 hypervisor.
Okay.
And I'm told that is beyond the limits of what real-time audio can handle going in and out. You, as I showed, you can run on the bare metal, you can run Ubuntu and then run the Docker runtime engine and the containers on top of that. You could also on the bare metal run VMware or some other hypervisor, and then run Linux on top of that hypervisor, and then run the Docker engine and the containers. That works as well and gives you a bit more control. What you can't do is run Mac OS or Windows, for example, and then run Linux on top of that, and then the Docker. That's too much to go through. You also can't run. There's a development platform called Docker Desktop, and that is meant for development. It's not meant for production use. It doesn't respond quickly enough for real-time audio to go in and out. On an iQs console, you may easily be literally subscribed to, let's say, 30 sources at the same time, each one at least 2.5 megabits per second. So, right there you've got, 75 plus megabits per second. And not that it's the data rate, but all those packets, they all have to be handled very, very quickly. And there's also CPU affinity. So if you run several iQSs in the same machine, there are other things that you need to do, and our support guys know about this, to just go ahead and assign, hey, Docker container A, you're going to be assigned to CPU, core number 10 over here. And Docker container B, you're going to go to core number 11 over here, assuming you've got a multi-core server. So there's things like that are needed to optimize the gazintas and the gazoutas and the CPU.
Do you have any kind of specifications for the horsepower on a particular machine? It's needed to do that with the Docker setup.
It's a good question. I should have a ready answer. I know we do have a document on our support.telusalliance.com website, or one of our help docs does describe this. If you get ready, I can find this for you, Ted, and get it to you. But I made it run. It's against the rules, but I made it run on a Core 2 Duo from an old Dell that has to be at least 7 or 8 or 10 years old.
No, that's what actually, if you could do bare metal on a Mac, the little 2014 Mac Minis are Core 2 Duo.
Oh, okay, gotcha. So would that be Linux running on bare metal?
I suppose you could do that. I happen to have Parallels, and I'm using that to run Windows in order to run natural music to program what's running on a PC over here. That's running Windows 7, but I also happen to have loaded Ubuntu for something else I was doing at the time.
And my experience with Parallels is kind of one-dimensional, but isn't Parallels running on top of the Mac OS itself?
Could be, yeah.
At least that's how mine is. So if I were to on my computer, if I were, I do have Parallels and run Windows. Oh, I need to update Windows. It's been a long time. So I got the bare metal Mac, Mac OS, then Parallels, then Windows on top of that, and then whatever I'm doing in Windows. So I think that's a bridge too far.
Okay.
to work properly with the real-time nature of what Docker wants to do.
Well, interesting.
I'm told. I haven't tried it myself, but I have run an IP driver in Windows, running in Parallels, running on Mac OS, and it's a little dicey. With the wind's blowing the right direction, it works fine, but it's also easy to make it not work fine.
Well, on your basic Mac Mini, it's only 4 gigs of RAM, so there's not much room to do things there. You can run out of RAM real quick.
Gotcha.
So anyway, just a thought.
Well, I bought my Dell server with 16 cores and I don't know 24 gigs of RAM or something. I bought it for $600. You can get off-lease Dell servers, pretty amazingly cheap. I've had good luck at SaveMyServer.com. The guy there is pretty reasonable and knowledgeable.
Cool.
All right. Well, I don't know if you'll be doing this tomorrow, but I think you'll see more offerings from more companies that run in Dockers, and we're certainly one of them. But we have our phone system, the VX phone system from Telos, now is available as a Docker. The cool thing about it being available as a Docker, instead of buying a Telos VX Prime Plus, which is our cheapest VX phone system, it runs $5,000 or $6,000. You get 8 hybrids in it, and about 100 phone lines coming in. With VXS, the Docker version of it, you just buy the number of phone lines you want, licenses, and the number of hybrids you want, and it turns out to be almost always cheaper than buying the hardware. Of course, you're supplying the hardware and running it in a Docker. Our Infinity VIP system also runs this way, so. It's certainly. Oh, and I'm pretty sure that we've got audio processors coming out that run this way as well.
That's pretty cool. Not to be confused with a pair of pants either.
Yeah.
Although that might be some interesting swag.
Gordon?
Yeah. I know this is really crazy and stupid and ludicrous even, but would this by any chance, at least in a small version, a 4-fader version, work on a Raspberry Pi with Ubuntu?
I think somebody,
the Pi 4.
Yeah, I believe somebody in our dev team has been working on that. Just as a side, I think they're not on the clock when they're doing that. And I'll ask. Well,
I don't know that you'd have to be, that you could be too serious about it, but
yeah. I will ask about that. I thought I heard a little twinkling about doing that, so I'll ask. I've got a couple of the Raspberry Pi 4s across the office here. I haven't played with them much. I bought them for my son when he said he was interested, and now he's not interested. Gordon, have you tried the Raspberry Pi? Was it the 400, the keyboard with the Raspberry Pi built into it?
No, I haven't.
It's very colorful. It's white and red. And it's cute, and it's a Raspberry Pi with a keyboard.
And there's another device out there. I don't remember what it's called. It's, for one of a better description, it's a Pi on steroids, and it's a lot more powerful than the Pis, and not a whole lot more expensive.
If you want to know about Pis, there's a guy on YouTube. His name is Jeff Gerling. In fact, his dad happens to be the chief engineer for Covenant Radio out of St. Louis. But Jeff works with just about nothing but Raspberry Pis and associated devices, Adreno and that sort of thing. And if you really want to learn about that stuff, go look him up on YouTube. He has got some really cool stuff on there.
Mark, it's funny you mentioned that because Jeff Gerling showed up in my own feed for the first time yesterday, and I watched one of his videos, the one with his dad in it, and I forget what I was going to go look in my history and see what it was about, but that's a great recommendation.
Yeah,
Jeff.
You can friend Jeff on LinkedIn, and he'll send you every time he posts something. He's really good. And his father's a really great engineer. I worked with him in CBS.
With Joe, yeah.
Yeah.
Yeah, Joe called me yesterday, no, day before yesterday with satellite issues. So
Just for your convenience, I just put in the chat, I put a link to the YouTube video that I watched yesterday that does have both Jeff and his dad, Joe Geerling, in that video. And he's talking about using Raspberry Pis as KVMs.
You could probably do a lot with it. You just have to make sure that watch your CPU usage, that you're not overwhelming the thing. I have Pis here in the house running my home automation system. Since I'm stubborn and wouldn't throw out my X10, I figured a way to get X10 to talk to the Amazon Alexas that are through the Pis.
Just as a kind of a personal thought about using a Pi to be an audio console, I'm not real optimistic that you'd want to do that. I think there's too many things not
too many things going on.
Yeah. So, but
But
that's just my
you
opinion.
got to admit it would be cheap.
It
Oh,
would.
yeah, if you could load a Docker up on a Raspberry.
And you can.
And I know Jeff is, he's created RAID arrays with these Raspberry Pis. It's
Sure.
just amazing what yeah, go watch his videos, folks. He's really good. I don't see your link on the chat here.
What would really be cool is taking a Raspberry Pi and making a remote console with it, because it would be light and easy to move.
Hang on, I actually sent it only to Dave Bialik. Let me, there we go. There's to everyone.
Well, you take one Pi, you use it to run the console, and then take another one as set it up as the remote console with a touchscreen.
Yeah. Well, and surely it'll work with the browser for the touchscreen. Actually, I did that here. I used one of my 2 Raspberry Pis I bought for my son and just opened the browser and went into the iQs and it worked fine. But that's not mixing the audio.
No. But the device that I'm thinking of, and I cannot for the life of me come up with the name of it, but it is it's similar to a Pi in that it's a little self-contained Linux computer, but it's a lot more computing power than even a Pi 4.
Not Adreno.
No, it's running true Linux.
Oh, okay.
So there is a YouTube channel. I used to watch this guy a lot. There's two of them I'm thinking of. One of them is called ETA Prime. He reviews a lot of single board computers. So that would be Raspberry Pi class computers. ETA Prime is that YouTube channel. And the other one is this British guy explaining computers. He compares a lot of different single board computers as well. If you go to YouTube and you just search single board computers, the 2 channels I just mentioned will be the top ones that pop up.
And danger, guys, when you're looking at the Pi Pi boards in Micro Center, your wife will drag you out.
No, my wife doesn't go into Micro Center.
Mine doesn't like sitting in the parking lot.
Well, we had the perfect arrangement until just before COVID. Right next to the local Micro Center was a Hobby Lobby.
Ah, there you go.
And we'd walk in and split, and I was usually done before her. But then they moved the Hobby Lobby a mile down the road.
Oh, that ended that deal. My
Yeah.
wife just lets me order them online.
So
I
if the Hobby
get
Lobby-
in trouble in Hobby Lobby as well, since I'm an avid electric train collector.
If the Hobby
They
Lobby's a
don't have
mile
that
down,
much train stuff.
if the Hobby Lobby's a mile down the road, which one of you gets to walk?
Hey, Gordon, you don't mean the big old board, do you?
No,
No, okay.
no. My boss has one on his desk, and I'd email him, but I know he's not readily available at the moment. Couldn't get an answer back quickly enough, but he has been doing that. Another useful tool for everyone that's out there will run on a Pi or any other derelict computer you have, as long as you can hook it up on a network. A little piece of software called Node-RED. And if you've ever used it, it's really a cool piece, cool utility software. If you've got things that don't seem to want to talk to each other, this thing will do it, among other things. Really useful, very, very simple programming. It programs, it's sort of like Pathfinder Pro.
I see it. You go to nodered.org.
Yeah.
You'll see about it. Low-code programming for event-driven applications.
Yeah, you can switch sources on nodes with it. I think I ran it. I ran it for a while.
Yeah. One thing that we've seen is when you have different destinations that want the same data in various formats, it makes a great format translator.
Oh, like RDS? Metadata?
Well, you get your data from your playout system, and then this will give you one version for your RDS, one version for your streaming, one version for your website, one version for who knows what. Just translate it. And not only that, but we'll even do different hardware formats if necessary.
I see it's available as a Docker as well.
Yeah. I mean, it's very useful for, it's a sort of a go-to. If you've got things that don't seem to want to talk to each other, it's a great interpreter. C3PO the hard way.
It looks like the next level Arduino.
Almost. I mean, what's nice is the programming is so simple. If you've ever I know Kirk knows about Pathfinder Pro. It's as simple or simpler than the latest version of that.
Nice.
Well, I think we're running out of questions finally, which is good for you. I know that you're available, Kirk, if anybody wants to send you a direct email. Did you want to throw a card up real quick?
Well, let's see. I don't have anything to throw up. The best way to reach me, my Telos address is kind of long, so simply kirk@harnack.com. So there's my name on the screen, kirk@harnack.com.
That works.
And I'm on, you can reach me on Facebook pretty easily too.
Well, we sure appreciate you taking the time to be with us today.
Well, Barry, I feel honored that you invited me to be on here. Thank you very much. And your group here, I've attended a few meetings in the past, and it's really an impressive group. Lots of names that I know here, and people that I might like to snag at some point to be on my own podcast. So there's a lot of brain power right here.